Hello, we are the Spanish River InvenTeam from Boca Raton, Florida.
Our team is trying to create an invention to diagnose sepsis more effectively. Sepsis causes an overreaction in the immune system, creating widespread inflammation that leads to reduced blood flow, leaky blood vessels, hypotension, and hypoxia.
Our prototype will mainly benefit those who are most at risk to suffer from sepsis. These include infants, pregnant women, chronically deceased, and the elderly.
Utilized our different skills effectively, got to know each other, and learned to capitalize on the constant stream of ideas from our team members in order to create our prototype.
At first, we primarily researched how patients were being currently treated for sepsis. Through our research-based meetings, we discussed ideas relating to allergy pricks, hydrogel lactate sensors, sweat sensors, and urine tests.
One of our team members came across the research on the use of carbon nanotubes to diagnose pancreatic cancer. Our group further dove into the idea of utilizing carbon nanotubes. We came across many difficulties throughout designing this prototype, such as conducting endless research to pinpoint the correlation between levels of lactate to electrical conductivity levels and to find an equally efficient replacement for the expensive multi-walled carbon nanotubes.
This is our lactate sensor, which is currently catted and backed by research. Certain lactate concentrations in capillary blood indicate sepsis, so the team made this sensor. Electrodes of an ohmmeter are connected to both ends, the anode and cathode. Electricity goes from the anode through the wire along the PCB, passes through the paper matrix which causes resistance, and to the cathode. The ohmmeter measures resistance. The disc is a matrix of paper coated in carbon nanotubes. They are microscopic sheets of rolled graphene which are very conductive. Our device uses antibody-antigen interactions. When lactate, the antigen in yellow, is present, it binds to its antibody, dehydrogenase, in blue. A higher concentration of lactate means more binds to its antigen. Before the test, the matrix looks like this. Electricity freely passes through, conducted by the nanotubes. When a drop of blood is added, the lactate in it will bind to the matrix. This creates a physical barrier. A computer algorithm can use data to determine lactate concentration given the resistance since they're directly linked.
With the current pandemic, our InvenTeam decided it was no longer safe to finish developing and testing our actual prototype in the lab at FAU. Instead, the research and sustainability teams have been working together to use a computer-aided design program called Tinkercad to make a 3D model to scale and confirm our plans for development and testing when we do have access to the lab again. The communications team has stayed active on our social media platforms, the technical team has been working on our pulse oximeter through Zoom, and the finance team has been determining how the rest of our funds can do the most good.
This project will be continued by graduating seniors in college labs such as Harvard.
We were all so personally invested in this project, and it really did have a part in our everyday school lives.
We want to thank the Lomosum MIT program and our advisor, Ms. Fish, for allowing us to be part of such an amazing opportunity.